Welcome. Today, we're diving into occupational exposure limits, or OELs, and how they guide risk-based containment strategies. We'll explore how setting these limits helps protect workers and manage hazards effectively. Let's get started with the insights from Dr. S.K. Singh. Containment isn't just a box to check for environmental health and safety. It's deeply connected to good manufacturing practices, stopping cross-contamination, and how we design our facilities. When we talk about occupational exposure limits, or OELs, we're really talking about protecting people from powerful medicines that can also be serious hazards. Workers face risks during high-exposure tasks like weighing, sampling, milling, or cleaning. Exposure can happen through inhaling dust, skin or eye contact, accidental ingestion, or touching contaminated surfaces. Every step matters. Let's start by understanding what an occupational exposure limit, or OEL, really is. It's a health-based exposure limit set using solid science and expert knowledge in occupational hygiene. OELs help us control how much of a hazardous substance workers can be safely exposed to. When developing an OEL, we look at a range of factors, from toxicology and dose-response data to how a substance affects specific organs, its potential to cause cancer or reproductive harm, and even how often and how long exposure happens. It's important to remember, an OEL isn't a one-size-fits-all measure of potency. Different substances demand different control strategies based on a full hazard assessment. Let's clear up a common misconception. A PDE or HBEL shouldn't just be treated as an OEL without solid scientific reasoning. These limits serve different purposes and protect different groups. Worker safety is the focus of an OEL, while PDEs help assess risks of product cross-contamination. HBELs take a broader view, supporting quality risk decisions based on health evaluations. So it's crucial to assess worker protection and cross-contamination risks independently, whenever they're relevant. Each limit has its own role, don't confuse them. When it comes to containment, risk assessment is the foundation we build on. We don't guess, we measure and analyze. We look at the process itself. Is it open or closed? Does it create dust? How does the powder flow? What's the batch size and frequency? Is there manual handling involved? Then we consider exposure, how long and how often workers might be in contact. We also evaluate existing controls, from engineering solutions to protective equipment. This flow guides us from understanding the hazard to verifying controls and reviewing regularly. The key: containment levels must be scientifically justified, matching the real risk. When it comes to containment, one size doesn't fit all. We choose our strategy based on risk. Higher risk means stronger, more reliable controls. At the simplest level, closed processing keeps operators away from hazards. Then there's local exhaust ventilation, which captures contaminants right at the source. But it's not about the equipment's name. What matters is how well it actually contains the risk. For the highest hazards, we turn to advanced solutions like isolators, automated transfers, and dedicated containment systems, tailored to keep exposure as low as possible. When it comes to managing risks, personal protective equipment, or PPE, is just one layer of defense. It's important, but it shouldn't be our first or only line of protection, especially for hazards we face regularly. Instead, we follow the hierarchy of controls. At the top, we try to eliminate the hazard completely. If that's not possible, we substitute it with something safer. Then come engineering controls, like isolation or ventilation systems, followed by administrative controls, things like training and procedures. PPE comes last, as the final barrier to keep us safe. When we talk about testing, it's crucial that we don't just focus on perfect, ideal conditions. Instead, we need to challenge the system with real, credible worst-case scenarios. That means looking at everything from personal sampling and area monitoring to how well containment holds up during normal use, and when things go wrong. Operator actions, cleaning, maintenance, even spills and equipment failures all matter. Testing isn't a one-time thing. It's a continuous process, from design, through installation, all the way to routine monitoring, to prove the system works as intended in the real world. We often think the highest risks happen during production, but the real danger can come later during cleaning or maintenance. When equipment opens up, hazardous substances can be exposed. That's why risk assessments need to cover the entire life cycle, not just routine operations. Before any maintenance, we identify hazards, assess contamination, and follow strict decontamination steps. Using proper containment, protective gear, and controlling access are critical. Every step, from filter changes to waste removal, must be carefully managed and documented to keep everyone safe. Let's talk about the improvement cycle, a continuous loop that keeps safety and quality on track. We start by monitoring, then detecting any issues, investigating the root causes, correcting them, and verifying that those corrections work. Finally, we review the risk assessment to see if anything's changed. When factors like material potency or process design shift, we need to reassess containment strategies. That's why monitoring and investigation are crucial. Control must be measured, reviewed, and improved. This means setting up a monitoring program that fits the risks, including exposure checks, equipment performance, and operator practices. When we talk about containment, it's not just about keeping the powder inside a box. It's about really understanding the hazard, controlling who's exposed, and proving that our protection works. We rely on occupational exposure limits to guide control, but those limits serve different purposes than other thresholds like PDE or HBEL. Containment has to be based on solid science and risk assessment, with engineering controls taking priority over just personal protective equipment. We also need to test containment under real conditions, and remember, cleaning, maintenance, and waste handling bring their own risks. Finally, risk assessments aren't set in stone. They need updating whenever processes, materials, or knowledge evolve. This is the risk-based containment formula. Understand the hazard, assess the risk, control exposure, verify performance, and review regularly. It's a cycle that keeps everyone safer. We want to hear from you. Did you find this training useful? If so, please like the video. Share your thoughts in the comments, especially how OEL-based containment is managed at your facility. Don't keep this to yourself. Share it with your colleagues in EHS, QA, production, engineering, and API teams. And if you want more insights like this, follow and subscribe to the Siphacos channel. Together, we're building GMP knowledge, strengthening risk-based control, and supporting safer pharmaceutical manufacturing. Thank you for joining me today. If you'd like to explore this topic further or have any questions, please don't hesitate to reach out. I appreciate your time and interest, looking forward to continuing the conversation.